Good day. This video would show how you can use the Power Amplifier test app for amplifier measurements. So first off, we have the VXG connected to the input of the amplifier under test, and the output of this amplifier is connected to the PXA. You'll have to take note of this configurations because this would apply to the settings under the Power Amplifier app. So now if we go into the mode, and if you have the license for it, this should be available for you to select. So let's click OK. And this is the interface. Now we'll have to go into the setup mode. So let's go to measurement setup. And we'll start with the measurement standards. There are a few radio standard presets. So in this case, we would go with a 10 megahertz FR1 signal. And just for your a sanity check, you could go into configure carriers to check that the bandwidth is indeed set to 10 megahertz. If in any time during the test you've done some changes, you might want to check the settings here are set accordingly. So now that we have the presets selected, let's set the signal generator. We want to ensure that the connection is established. So let's go to connection management. Because I have the IP address for this previously registered, this is now prompted. If it's not, you could always enter the IP address and optionally name the signal generator so you have an idea which signal generator you're referencing. Add to the generator list and hit connect. So in this case, because I already have this connected, I'm just prompted with an option to disconnect. If the once the connection is established, you should see that this is green and the information tallies with the signal generator you have connected. So in this case, I do have a M9384B connected. Now we'll move on to the next step, which is to select a reference signal. So we do have some waveforms predefined here. For today's video, we would select the 5GNR uplink FR1 signal that is 10 megahertz wide and centered at 1 gigahertz, and there's only one subframe. You can always create your own signals via Signal Studio on VXG and import that over to the spec end. So if you just select and put them into the dedicated folder, you should be able to select them. So now I have these waveforms selected. It looks like my amplifier is already distorted. So let's go into the amplifier tab and fix this. Because we are testing a power amplifier, I would like to control it based on the output instead of on the input in this case. And as you can see, it immediately went into the linear region. It's not distorted at this moment because the power levels are at, they're pretty low. It's only about -5 dBm for this amplifier. I'll just go ahead and preset some settings here. So just to protect the amplifier, I'm going to limit the maximum input power into it. The amplifier I have connected has about 22 dB of gain, so I'll include that in. And instead of keeping it at a negative power, let's set this to something higher and see if we could hit this, give it some distortion. So I've set it to 3 dBm, and as you can see, it started to distort a little. But if you notice under pre-DPD, the output power is 5.43 versus 3 dB, and that's where this power server tab is great because it controls it to ensure that's always around 3 dB. I'll just turn the tolerance a little higher, so to 0.1 instead of 1 dB. And the output power now, it's a little better than what it was before. So now that we have that, we can go ahead and turn on the DPD. There are a few DPD models available. So for this demonstration, I'll put memory polynomial. And I'll leave the rest as default. So now if I turn this on, you can now see that with the DPD, this is definitely a lot more linear than it was before. Just to note though, in this ACP graph, the PXA would need, the bandwidths needs to be at least 3 times more than your carrier frequency. So I had 10 megahertz signal, and this is in it's a very narrow bandwidth compared to the available bandwidth that I have on the PXA, which is about 160. So we have no issues there. But if you're looking at signals that are about 100 megahertz wide, you might need to upgrade your bandwidths to the 500 megahertz. So that gives me an idea now, which is great. But as you can see, EVM measurements are still not available. And this is where we would need to turn on the second application tab, and that would be 5G NR modulation analysis, as the presets would be imported from this modulation analysis over. So go to 5G NR modulation analysis, and let's stick to the normal view. As you can see here, it might look like it's not properly set up, so let's go to measurement setup as well. Similarly, this is not an uplink, not a downlink, I'm sorry, it's uplink. I'll change that. I'll also change the measurement standards because this is now 10 megahertz instead of 100 megahertz. Component carriers, similar to the power amplifier tab, we need to check that these are set up correctly. Now we can kind of see something being shown, but it's still not quite right. So let's go to measurement time. We know this is only has one subframe, so I'll change that. And let's update the analysis boundary. It's also based on the subframe, and I want to have it triggered on the subframe. You can see now then there's a sync error, and that's related to the trigger. So this should be an external trigger. Let's keep it there. And I don't really need it to be this wide because it doesn't need to sweep that wide. So I'll just change it down so we can see. So we do have some measurements here. The IQ diagram or constellation looks clean. We can now go back to the power amplifier app and have the settings imported over. So we would now go to PA measurements, which would then prompt all these measurements. So let's go to PA measurements and go to EVM, and we can turn this on. So it would now say that it's synchronized with the 5G and our EVM measurements. So let's close this. And as you can see, I now have the EVM channel power measurements being populated. Now if we click and go back, we can turn on the DPD again. And as you can see, that definitely helped improve the signal. And the EVM has also improved from 0.94 to 0.33. So with that, you can do a few things, which is such as extracting the PA model. And that can be done here. So that's all I have for today's video. Thanks for watching.